Okay, so we're going to cut this. Okay, we're going to do the same on the other side. Notice that everything disappears so that we can actually focus on what we are doing. Perfect. After this, we're going to survey these little cut surfaces. So I'm going to take this one, and that one, and we're going to survey. And this is similar to our surveyor, but it's separate from the block out module. So we're going to survey and block this out. Notice that I've got all of these 3 components. If it's a 3-unit bridge or whatever, we would also take those contacts into consideration. Okay, are you still with me?
Yeah, I'm still here.
Okay, so this procedure blocks it out and it makes all different types of things, objects and whatever underneath it. So you can see in the transparent gray, that's the block out version of the die. Okay, so the next thing we're going to concentrate on is we're going to add a little bit of a margin to this, because when we're milling or whatever, we need a little bit of a margin. Usually it's around about 0.100 microns. Okay, so let us make a small margin around it. So you can see that margin in blue. You can edit this margin, you can delete it, you can make a bigger margin if you want to. So this is all there. So once we've got that, we've got to focus on the die spacer, because we need a cement spacer in this thing. So let's click the cement spacer. This, by default, I've got it set to 100 microns. You can adjust that to whatever you want. So, if you want more die spacer or less or whatever. Okay. We're going to accept this die spacer, and then we're going to add a safety zone. There is an auto default, so it does it all in one hit. So you don't have to worry about that. But that's in case you want to change something. So this one, the zone is 0.5 millimeters thick. So, if you want to make a thin coping or whatever, we can set that differently. So we're going to accept the zone. Notice that we've got the mark, the dies have all been marked. So if there's ever an error, we can clinically look back at the margin and we can say, okay, look, the margin could have been somewhere else or whatever. So this has been recorded. Okay. So following that, we need a tooth. So we're going to go to our wax up module and we're going to import a generic tooth, or you can take one from your tooth library. Other alternative is you can cut out the one next to it so that we can get a good mirror image of the tooth 1-1. Okay, but for this example, I'm just going to take our tooth library and I'm going to choose the tooth. Okay, and we're going to put this into position. Okay, so here what we can see the green zone. We can see our pencil line, scaling this a little bit. So once we're sort of happy with the tooth, doesn't look 100% like the other one, but that's just for an example now. Okay, the next thing we want to do is we want to edit this tooth so that we can pull it. Okay, so we're going to go and edit this here, speed edit. Okay, and we want to then pull this mesh to just over where the margin is, something like that. And notice that it's actually going inside the green zone. So we can quickly fix that by using the G key, something like that. So now we know it's thick enough. Next thing we're going to do is we're going to cut it and we're going to finish this crown. Okay, so we're going to click here, finish crown. So we'll just wait for it to do its thing.
So Michael, the green zone is just so that we don't go too thin.
Yes, because if we're cutting the occlusion with the articulator or whatever it is, I'm not going to focus on the occlusion now. That green zone is going to be exposed. And if that's exposed, we can quickly just sculpt and push it back out. So it's quite easily to do that.
Okay.
The next, so that's almost finished. We still have to think about two things. We want to smooth this edge down. So we're going to smooth it with protection, which means it's protected on the inside. So we cannot damage this mesh structure. So here, just take this and smooth the edge down nicely like that. Okay, so that's good. Okay, following that, we're going to still do the contacts. All right, so we're going to expose these that we had earlier. And we're going to, again, we've got an automatic thing to do that. So you don't have to each time do this manually. So you just click on auto and it does it for you. But if you want to do it or do it differently, I'll just show you what happens here. So this takes our blocked out models and it expands it to 50 microns. So if your crowns are too tight, for example, you're going to set that to 100 microns or whatever. So if I set this to 100 microns, it'll just expand it outwards. Okay. So let's leave this at 50 microns. Okay. And then what we're going to do is we're going to accept that. Okay, so now we've got these objects. We'd like to now make sure that the contacts are nice. Okay, so we're going to go shape contacts, and then we can see through this model. So if you wanted to change this, for example, I can click on the minus or the plus, and we can take it down a little bit, or we can add. So if you've got a molar, you can add more contact. So here maybe the contact is a little bit too much into proximal. I'll take it away.
So
Okay,
you can
and then
broaden the contact area, Michael. So if you don't get a food trap, say in a molar situation, you can have a nice broad contact point, which is what we are often requested to do in a laboratory setting.
Correct. So this crown is finished. This crown can be milled in Emax or monolithic or whatever. Okay, yay, done the first one. Cool. So
I'll look for the
I'm going to
little
go to
sign. Hold on, I've got to give you a little party thing.
the thumbs up. Okay.
Awesome.
Okay. Sweet. All right, so that's a fun central insight.
Here's a
Yes, please
question.
ask.
Yes, please.
Yes.
Can I see somewhere the minimum thickness of the crown itself? Can you show that?
Yes, you can. You can go into color map if you want to. So let's map this. Okay, this is going to be the one I'm mapping to, and this is my heat map, view heat map. All right, so we can see the blue. The blue is everything 1 millimeter away from 1. The red is 0. So there's 4 colors. Okay, so you can take each color is 0.25. So if I, for example, take this one and I slide this, okay, so the other way around. If I take this, I'll be able to see how thick this, I think I'm meant to go other way around. Just give me a second. The red one. Yeah, as the red increases, you'll see here, for example, this is 0.5, okay? So this takes a bit of practice and knowledge. So the red here is 0.6, then the yellow, the green would be above, and then the the blue would be 1 millimeter. So you can actually sort of see the thickness.
Can you cross
Does
section?
that answer your question? Yes, you can cross section as well. Okay, so here we go. We can see there's a bit of a die spacer that's been cut. there. And yeah.
So you can take a measure with a measure it add-on.
Well, you can as well.
Yeah,
So there's
yeah.
a few different ways.
But the green
Okay,
safety zone, how much was that? What did you say? 0.6, the safety zone.
Yeah, so you set it. So if you want it less, you'll make your safety zone less. And what actually happens during the procedure of making the crown, it actually shrink wraps onto the safety zone. So if it's like 0.4, it will actually touch the safety zone. So
yeah, so you can't go below that, basically, yeah?
no, yeah.
Excuse me, quick question.
Yes.
Yeah.
With the production of the crown, you produce an STL, of course. Is there a construction info file that's created or no?
No, you export the STL file and then you'd use equipment that programs which can use STL files.
Of course, of course. Thank you.
Yeah. All right, so let's continue and go to the next one. Okay, let's have a look. All right, so, okay.
So here you're working on a mesh, not a closed model, Michael.
Yeah, so this is a normal desktop scanner, for example.
Okay.
All right, so let's start the procedure. So I'll attempt to do a few things with the specific model. So first things, we're going to remesh the lower one and hide it away. And that becomes our antagonistic. And we're going to start the procedure. Okay. So again, we're going to then cut out our mesh as I've shown you before, and we'll do all of this. And then actually I'll call up the next one because we've already seen what I'm doing there.
So you just lay out the margins and then you're putting in your yellow zone. Yeah.
Yeah, these are this, I call them surfaces. Okay.
Okay.
So let us, for this example, let us make, yeah, monolithic. Let's make monolithic crowns. Okay. And then we can make a coping structure for casting or something that's been reduced. Okay, so again, we're going to survey these and block them out. All right, perfect. Next thing is we're going to select which ones we want margins on. So we're going to want margins on these. We're going to add some margins. Okay, they are highlighted in blue. Next thing is we're going to choose which ones we want die spacer on. So you can do one, you can do them all or whatever. Let's just do the auto default so that it all does in one hit.
Michael, when you say margins, these margins are slightly thicker to compensate for, so that the edge doesn't break.
Yeah, for chipping.
Yeah.
That's correct. That's correct. Okay, so here we go. The next step, we're going to import teeth.
So this is your safety zone, the green one.
Yeah.
Yeah.
So we're going to take this one, this one, this one, and this one, and delete the rest. And let's put them into position. Okay. Let's have a look at the antagonistic, which is over here. Yeah. So at this stage, I'm not, as I've said, I'm not going to focus too much on occlusion because I've still got to write some scripting for it. Okay. So we're going to do exactly the same thing. So we're going to go into edit. Was there a question?
No, we'll open the floor for questions in a minute. Just go through this process.
All right, so what I want to do is I want to make sure that it is over my margin. So what I'm doing is I'm pulling it like a sock, okay? Just like that. Sometimes we've got to stretch it because, I mean, we need to make the tooth fit, okay?
Mhm.
So we'll go to the next one. Just take this up like that, like this, pull this across, like that. Okay, that's fine. Bless you. Let's do the next one. Is that you, Wolfgang?
No, no. I've just hit the mute button, sorry.
Okay. So let's do the next one. Pull this across. That's good. Okay, so we're almost ready to finish these. So basically what I want to see is I don't want to see them too far away from the actual model. So this one as well, let's just bring that closer.
So while you're just pulling it over the margin, you don't want to go excessively, you know, over contour the crown. Because will this determine the contour close to the margin?
It's sort of a little bit the emergence profile. So we don't want it too far. We don't want it standing too far away. Okay, so let's complete these one by one. Okay, finish. And then the last thing is we need to think about contacts. Now that is very tricky because the tooth library, sometimes the contacts aren't exactly the way we want them to be. Okay, so this will just take a little bit of time. So
well, especially with anterior incisors, Michael, the 2-1 and the 1-1, you've got to kind of follow the patient's, you know, smile and things like that. And according to the lower teeth.
You don't want the contact to slant in either way. You need to get it exactly down the middle, don't you?
Where you want it, yeah.
Okay, so all of this is doing, it's joining the actual mesh of the tooth library to the actual underneath structure. Okay, lucky last.
So this will automatically delete the die spacer as well, Michael, while it's doing this?
The die spacer has been cut on the inside of the crown, and the undercuts have also been relieved at the same time.
Okay.
Perfect. Okay. So again, what we want to do is we want to smooth them. What I'll do is I'll smooth all of them in one hit. So I'll join them up and click on smooth. Okay. So that's basically so I can get a nice, even and smooth margin here. Okay. So we'll just take this and smooth it. And because it's protected, we can sculpt on it. So we can do whatever we want to do on the actual mesh, and it won't hurt the inside fitting surface at all. Okay. So that's looking good. So these are basically almost finished, ready to be milled out. Okay.
Now it's just the contact left.
Let's talk about contacts. Okay. So we're going to expose our abutments, these here, this one and this one. And this time I'm just going to go on the automatic. So auto defaults. Okay, so that's done. We're looking for our interproximal contact. Okay, so this has been made behind the scene. So let's use this one, and I'm going to position it. We're going to duplicate this one, and we're going to duplicate this one as well. Okay, so then what we're going to do is we're going to look at it from the front view, and we're going to position these correctly. So if we've got the lower one, the antagonist, we will now be able to move this one accordingly. So let's move this one. We can see it's slightly slanted. Okay, so we can move this dead on straight, which we've done. Okay, and I'm happy with that. Okay, let's move to this one. So I'm going to look at it like 90 degrees, and we're going to then shift this one and make a nice contact as well. So let's, okay. Maybe
Initially,
like,
when you bring it in, are they parallel to
okay.
each other or not? Are you going away from that?
They are parallel, and you'd probably use that parallelism to your advantage when we've got posterior bridges.
Okay.
When it comes to anterior bridges, sometimes it's not the case. It's a little bit more tricky than that. Okay, so what we'll do is we'll do exactly the same thing. Just make sure that we get a nice contact. So just, yeah, I think I'm happy with that.
So
Okay.
can you broaden the contact again, or at this point, or?
Wolfgang, good question. You see, this is 0.1 millimeters. So if your crowns are too tight, you can set this a little bit larger. And what that does is that it's going to make the contacts a bit looser. So we've got complete control over the contacts. Not only the contracts adjacent to the actual teeth, but also in between. This 0.1, if I set it to this is 10 micron space. I mean, I don't know what a carbon paper, the carbon paper to check, I don't know how thick that is,
Or flossing,
but
yeah.
yeah, so we can set this to 0.2, for example. So we've got some good control over this here. Okay.
Yeah.
So now here's a trick. We have to focus on each and every one. So let's do it. I'm going to first separate these because they've all been joined. Okay. So I'm going to take this one, and we're going to then choose this one to do our contact, shape contact. Okay. So what that does is hides everything else. You can see we don't have contact. Okay. So let us just make some contact. Here we've got contact, we can see through it. Okay. So, okay, so say you want more interproximal. Okay. We're going to then cut this contact. Perfect. That one's done. So, and it disappears. So next one. Okay, that one looks good. That one's a little bit too much, maybe. Take it down a little bit, like that. Okay. Then same thing, cut contact.
This is great.
Beautiful.
Because in the lab, the normal technique, it's not so easy to create a wider contact because you've got to, fight in the ceramic oven more often and all those things, So you got a good control here.
Yeah, we've got very good control. Cut contact. Okay, lucky last. Shape contact. And we can take the contact down a little bit as well. Okay. Yeah. Okay. Cut contact. Perfect. Okay. So let's see what we've got. Completed teeth. And let's hide our contact cutters. You can see we've got beautiful contact all the way through. Yeah, you can see it. Nice flat and wide contact.
So if this were a bridge, could you determine the connector this way?
Yes, and I'm going to head down to making a cutback bridge after this, or copings, for example.
Yeah.
So yeah, good. I think we've done
Wow.
quite well. Quite
Give you
happy,
the thumbs
quite happy
up.
with this. Awesome. So that's
Where's
another
the
success.
little, did you get it? Well done, Michael. Awesome. Are there any questions?
Let's have a look at the mesh structure. It's looking good.
Yeah.
You can see we've got our 0.1 margin going around, which is our safety, and other than that, it's fine. Perfect. Okay, so let's go to something else. I think it's this one. Yeah. Yeah, that's it. Okay. All right. So sometimes what we want to do, is it this one? I'm not sure now. No. Okay. Let me just. Okay, we're going to make cutback copings. Okay, so we'll just survey this again. I'll take this one into account as well. So let's survey this as well. Going to head down this and block it out. Okay, so this is for layering technique, and we can either we can join all of them. Maybe I'll join them all and do them all in one go. Perfect. All right, so we're going to choose these, put a margin on it. Okay, and what we're going to do is we're going to choose for die spacer and our safety zone. Perfect. All right, now let's make some copings. Okay, so we're going to select our safety zones. Let's try and do all in one go if we can. Should we try all in one go,
I
Wolfgang?
think that's a good idea.
All right, select the zones and make copings.
And I time you, Michael.
How quick it is to make. So these by default is 0.6 millimeters. If you wanted to increase them, you know, you can set them there. Depends how thick you can mill them. Okay, so 0.6 for now, accept. Okay, so these are our layers and we want to engage in layering them. Now, in giving them more support. I mean, if you would print out of wax or laser sintered chrome cobalt, for example, we obviously need more support. So here's my antagonist. And what I'll do is I'll go into the wax up module and we'll choose one of our ratio so that we can actually have a quick view of how our tooth ratio looks. So that's our tooth ratio stencil. I'm going to move it sort of towards the midline and I'm going to scale a bit. So I'm looking at the laterals, something like that. And of course, we then predetermine the length because we would need to know. So there's a lot of support missing, as you can see. Just move this along like that. All right, so let's make some support, okay? So in the copings here, we're going to edit this. Perfect. And now what we're going to do, here comes the magic. We're going to bring this to a specific height so that we can give it some support. Okay. and we'll go to the next one. And all we're doing is we're pulling this structure to a certain place like that. Okay, so it's looking quite good. Wolfgang, you don't have to wax anymore.
Ah, geez, it's a pleasure, Michael. Hey, waxing and scanning is all gone then.
No more hottie for you.
Hey, I like my hottie. My
Yeah.
dipping of the wax.
Yeah. Okay, so we'll just hide the antagonist, and then we're going to just have actually we need the antagonist because we need to see where these are. So just move this forward a bit. And of course we'd have to cut them, right? And it would be good to use the articulator, but in this tonight, I'm not going to be using the articulator because I've still got to do some coding for that. But what we can do is we can cut them. Okay. So in the wax up, we'll just delete that guide that I had. Here, delete that. And we're going to, here we can see we're a little bit thin. Yeah, there. Okay. But that's all good. Okay, we'll just leave it like that. Oh, what have I done now? Doesn't matter.
Where it's thin and the green is popping out, then it will take that measurement into consideration.
I've got a safety which actually brings it above the green.
Okay.
So, but what I wanted, what I really want to do is I just want to cut these copings. So we're going to choose them and cut the opposite so that it's okay. Okay, that's fine. So that's cut. So let us convert these into our finished units. Okay. Okay, complete copings. Let's see if it works all in one. Hopefully it will. I'm not sure. If not, then we'd have to do them separate, which we may have to. I don't know. I've got a feeling we may have to, but we'll see. The anticipation is overwhelming.
We had a question on options for cutbacks. Yeah.
Perfect. All right. So here, the green, we need to change the green because it's too thin. Okay.
Yeah.
So I thought it was going to do it, but it obviously didn't. But that's okay. But what we can do is we can just do this. There. Okay.
So
Perfect.
the copings are ready for milling.
Yeah, I would definitely still smooth them down.
Okay, just on the border.
Like on the border like that. Let's hide the antagonist. Yeah, we can see where it's been cutting. Perfect.
So while we're talking about cutting in the bite, Michael, can we offset the bite? Remember how this is quite important because we don't want high bites when we cement crowns. So it would be good to offset the antagonist, yeah?
Exactly, it would be good. Now, of course, sometimes we would want to add like more of a collar, for example. You know, we can do that by bringing this out if we wanted to. So we can actually make we can bring this out if we want to actually make a bit of a collar if we want to. Okay.
Okay, so you're just sculpting that out quickly.
Yeah, that's right. Okay.
Okay.
And then we can also we can crease it then like this.
Oh yeah. Yeah.
We can crease it inwards, and also we can take this here, and we can make it sharp, nice and sharp, you see?
Yes. Yes.
So something like that, and then we can smooth it as well. Okay, perfect.
Wow.
Okay.
Fantastic. Okay. What about cutbacks? There's a question about that.
With cutbacks, I'm still developing my cutbacks, because what I want to do is I want to make sure that we take about like 0.5 or whatever millimeters away from our tooth library. So when we bring in the tooth library, then we can, it's a little bit like the bleaching module that we have. So what we're going to do is we're going to paint on a layer where we want porcelain to go, but instead of adding it on, it's going to subtract it, and it's going to leave a nice thin margin so we can actually accommodate porcelain. So I'm still busy developing that. So
So thanks for that.
that's in the pipeline.
Mhm.
Okay. Excellent. So I was going to show one more thing, if we have time. How much time have we got?
15 minutes.
All right. So let's quickly go into this. Actually, I've got an inlay. That's also quite good. So if we can do the inlay and the other one, that would be very good. So inlay was always, inlays are quite a big deal for me, because it's a challenge to make inlays. And so the procedure is, it's actually very similar to what we're doing. So let's head down and see if I can actually make an inlay. Okay.
Is that because the offset normally is outward bound and now it's going to be inward bound, kind of?
No,
No.
not really. It's just the complexity of the mesh.
Okay.
I have managed to do post crowns as well, so we quite well off, and veneers as well. Veneers is not an issue at all. Okay. So from here on, we're going to survey, which is good. Block it out.
So the procedure is almost the same, Michael.
Yeah. We can make bridges with in one go. I'll demonstrate that if we have some time as well. Okay, so that's that. We're going to just add a margin to it, thin margin, and dye space as well. Okay, in the wax up, import our tooth library. Choose a tooth, that's good. All right, we'll leave it like that. Oh, what am I doing? Like that.
Okay, so you're just pulling the mesh over the margin again.
Over the blue line. It's got
Yeah.
to be over the blue line.
Yeah.
Okay, here we're rather thin as well. So what I want to do is we can bring it out by exactly 0.5 by clicking on this one. It'll just pull it. Okay, so it's just pulled it. And then yeah, I think this should be okay. Okay. Let's try this out. Okay, yeah, I think this is fine. All right, so let's finish it. Let's hope this works. The countdown. Perfect. Okay, let's smooth it. Smooth it down a little bit to get the mesh nice and even. Yep, that's looking very, very nice. Yeah, I quite like that. Okay, and exit. Okay, here we go. Nice inlay.
Wow. Awesome. Awesome.
Let's have a look at the mesh structure. And if you notice carefully, you can see there the indent here. That's where the die spacer was.
Yeah.
So it gives us that little bit of a die spacer cement gap. Okay, it's looking nice, very nice. Okay, excellent. I
Awesome.
was going to show one more thing, but I think we're out of time, isn't it?
You've got 10 minutes, Michael. Then we've got 1 hour.
Okay, I'll just have to bring in my next file. I think it's this one. Yeah, it's this one. All right, let's do this quickly.
So, Michael, what would you say time-wise would you spend on making a coping or crown?
Well, how many have we done in this span of time? Roughly?
Yeah, I guess you've made a few, eh?
We've made quite a few.
So most of the module is automated because you haven't really pressed so many buttons. You know, you draw the margin, then you click 1 or 2 buttons for the die spacer and the green safety zone, pull the mesh over, and then you basically finish it. And of course, the context. So it's not too hectic, is it?
No. So well, we can't really see a margin here anyway. My mouse is playing up a little bit, but hopefully it'll last. Okay.
So you're demonstrating the bridge now.
Yeah, in one go. So we do everything. This is a bridge we would then maybe do an Emacs and lay on top. Well, actually, we wouldn't do that for posterior teeth, but for perhaps it's just a demonstration of doing it in one go. Okay, so it's not case specific, this one. Okay. Okay, so what I'll do is we'll just bring in the wax up and put a few teeth in there. Okay, that's good. Okay, that's looking good like that.
Is that because you want to design where the pontic goes, the tissue fitting surface?
I'll show you what I want to design. So in the wax up, I'm going to be taking this wax up. I'll just hide the fitting surface, and we're going to choose these 3 teeth. Then what we're going to do is we're going to make a frame, like a metal frame or something, which is cut back. Okay, so make a metal frame, and we can set the thickness to that, and that becomes our metal frame. Okay.
Jeez.
Okay, so all we need to do is join this up to what we want it to join up to. So let us do that, and hopefully it'll all work in one go, but I think it will work in one go.
So when you had the tooth library, all those teeth were individual, and then you pressed the button which joined it, and then it reduced it. automatically?
Yes, it's reduced automatically by X amount, but you can change that, how much you want it reduced.
So you
Okay.
you can set the X amount. Okay.
That's correct. Okay.
So if
so let us
this were a metalwork bridge to fire porcelain on PFM old style, you could use
well, you
that.
can lay
You layer
these
onto
days
that.
you can laser printer these frames. Don't forget.
Yeah. Or of course you can do a full zirconia build-up over that if you want to.
Yeah.
So zirconia, yeah, milled, and then you layer a bridge over that.
Yeah.
Okay. So it's a bridge
Okay.
frame. Okay.
Yeah. So we'll just hide the frame and do one more. Let's just mark out this margin here.
So you've got perfect control over the fitting surface of the gum where you want the pontic to lie against.
Yes, because we can outlie where we want the pontic to fit in. And if you wanted to countersink the pontic in, you'd have to then just sculpt away the gum a little and push it inwards.
Okay, so you can indent it a little bit, sort of blanch it slightly.
Yeah. Excellent. So let us quickly survey these. And it's all color coded. So the yellow ones, we know they're for the top, the green ones are for the bottom. And once it has been surveyed, it comes out a different color. So we can't get confused. But what I plan to do is the menu will be color coded so that we can't get confused in that. Okay.
So there is a question here. You know how you brought in the tooth library and then you reduced it? Can you do that without reducing it? So just have the full contour bridge?
Yes, you can.
Okay.
You can have what we do is we voxel remesh those 3 teeth, the actual bridge,
Yeah.
and then we can join it up in one hit. So we don't have to make contacts and all of that stuff.
Okay. Yeah.
Okay.
So I hope that answered that question. Yeah.
Yeah. Okay. So what I'll do is I'll just add a bit of margin around it like that. And then we're going to put our safety zone and our die spacer. Okay, which is done automatically.
Yeah, just following the same procedure.
Yeah. Now what we're going to do is I just want to expose my metal or my frame. Okay, like that. And we're going to edit this. So we're going to do exactly the same thing.
Yeah.
Edit, and I'm going to pull this to my margin.
Yeah.
Okay.
So the question here was, with the veneer bridge, do you follow the same procedure?
You follow the same procedure.
Exactly the same. Okay.
Yeah. So basically what I want to do, I just want to make sure that this is correct. So let's just drag this to the beyond that margin like that, the blue line. Like that. So we're just pulling it outwards like that. That's good. That's good.
So you could then make a model with a reduced, pushing the gum away, and then you can retrofit that bridge onto a printed model.
Yeah. So let's just take this way. Sorry. Okay. Takes a little bit of practice because it's like, even though I've sort of written the program to drive it, it's like, you can build a car, but you don't know how to drive it.
It needs practice.
It takes a while sort of to practice. Okay, so let's just put this.
What happens
above
if
the
you
line.
don't get it over the line, Michael? Just a random question.
All right, what happens is it then, when it fuses, it'll be too thin. Okay.
Okay, yeah.
So we just want to make sure. Okay, so just make sure that you've actually selected a mesh and pull it
Yeah.
over like that.
So here
All
you're
right,
just
so
using the G key and proportional editing.
yes, yeah,
Mm.
just like that. That's
Yeah,
good. All
yeah,
right.
yeah.
Okay. So let's do this. You see here, I've got a safety zone. I shouldn't have pressed that one for a safety zone because now it's going to cut away die spacer. So that was one error that I've made. I was only supposed to choose those two to actually put my die spacer. But
Okay.
anyway, it doesn't matter. For now, it's fine.
Yeah.
All right. So let's finish this. Okay. So we're going to click on finish it. Let's see what happens.
So yeah, for full contour, you just do exactly the same.
Exactly.
But you have to,
yeah.
you've got to outline your contact points. Mm.
How do you mean
Well,
outline the contact
yeah,
point?
you're
Oh
trimming.
yeah.
Yeah. Mm.
On the adjacent teeth,
Adjacent.
of
Yeah.
course.
Mm.
You've got to do that.
Mm.
Yeah. Okay, we'll just wait. All right, perfect. Cut nicely. I'm more than happy with that. Okay, we'll just smooth the margins like this. That's all good. Excellent. What this does, it actually brings it to the actual your margin line when you've outlined it, and then you can be sure that it's exactly fitting everything. That's nice. I'm happy with that.
Yeah. So if you wanted to make the bridge connectors thicker, what would you do?
Well, look, Wolfgang, I can
Yeah.
expose my shell. Okay, this is my initial shell,
Oh, of course.
and then
Mm.
okay, then I've got a good indication where, because then what I do is I go add strength, and then like we've discussed, we can do that with a solid bridge as well. Okay. So
Okay.
here, you know how we wax in German, we call that Geländer, and then we can actually put some more strength where we want more strength.
Okay. So
Like,
if you wanted, say, a bite spot just in zirconia, so say this is a layered bridge, okay, but you want a specific bite spot in zirconia, you could just
there,
elevate that upwards. Okay. Awesome.
yeah,
Awesome.
and then you cut it out.
You cut it
It's
out.
as easy as that.
So the weight
Yeah,
bearing, occlusal weight bearing is on the zirconia and not on the ceramic. I like that.
exactly. And then we can crease it. We can put a, it's
Yeah.
exactly like when we do that with wax and so on.
Mm.
So yeah.
Mm.
Okay, I think yeah, it's all good.
Can you show us it floating in space? Just detach it. Oh yeah, yeah. I see
Okay.
with the die spacer. Yeah, yeah. Okay.
Yeah.
Oh,
Perfect.
nice. Good job, Michael.
Beautiful, beautiful.
Mm.
Okay, I'm going to stop sharing my screen, and I think if there's any questions, please feel free to ask, or comments or suggestions. I'm open to as many suggestions as what we can get.
There's one question. Will there be a test module before it goes on sale?
All right, I'll just
No,
okay.
we're going into beta testing in the next 2 weeks, and we will be selecting some people that have currently got a grip or master onto the other modules, and also have access to a milling machine. So that's quite important. And after the beta testing, we'll get the feedback just to maybe tweak the program a little bit, and then we will release it for onto the market.
That's awesome.
Cool, awesome.
Hey,
Awesome.
Wolf,
Yep.
I lost the last one. When will be released for the beta testers for the?
Michael?
I'm hoping in 2 weeks time from now, because I want to
Okay.
make sure everything is correct. So give it 2 weeks. Yeah.
Yeah. What I realize here, maybe Baptiste, but Tyson. I have problems with French words, like German words.
Yeah.
I saw here just watching that probably this tool will open a lot of space for creativity. I probably you get to see, like, I am crazy doing this, but this is like all the time here. We will come up with different approaches for this probably.
Yeah.
I see here that you have like a shelf of tools to tweak and make be creative. Because I was looking, you work and I connecting with other things that I do in Blender. I say, hey, but if I go from this way or that way, I can improve results. So like experience driven, we will have different to drive this tool.
That's right. I think we'll just steer the user into a workable module, and then you can work outside of Blender and use your creativity to do whatever you want from there on. So we can't cover everything, but we will cover everything that's required for Crown and Bridge, and then the rest you can add into it from your own experience.
You will place the table and some of us will start giving more types and forks and tools.
So you were breaking up there, Ivan?
Oh, basic, you guys will place the table and we will start working with knives and tools. And
That's
forks
right.
And bring
That's
more
right.
tools to the table.
That's right.
Awesome.
Well, we do plan to sink these little dies into, you know, the dies that I've cut out. We can then sink into model bases. And Wolfgang's been working quite hard on that. You know, the one Ivan with the model base. Can you just, Wolfgang, just demonstrate how it's, can you demonstrate how it works or not? Or just the
yeah,
clipping
I'll
or
just
something?
have to share my screen. Just hold on.
After I saw you doing like the blockout creating dies, I understand what Wolfgang is asking. What for the base. Now I got.
I'll just
Yep,
share
so-
it. Just a minute. Share.
So we can take these little dies where we've cut the surfaces, it extrudes downwards, and those are the ones that we can put in there.
Can you see it?
Yeah, Wolfgang, I can see it.
So we use the base to actually cut out the serrated teeth. So each one of these is split by, I think it's 100 microns a cut. So the idea is you can either print the base with your own printer. It has a magnet in the bottom. And then we have an articulator table. I've got to just expose that. Just a minute. This part here will connect, the lower bit will connect onto the articulator, and it'll also have a magnet. So this means that you can just sync the blocked out units that Michael has created from a mesh. So we don't actually have to make a model. And then we can just sync that onto a base there that's contained in this model. And then just with a vertex cutting tool, we can cut it. So this is a very quick way of making a model. And because you've got it on the articulator, you can just cross between, you can take any patient's dies and fit it into this. So it's got many benefits that way.
Well, Wolfgang, the beauty of it is that because, you know, when you use a desktop scanner, everything, there's just mesh everywhere with holes and everything everywhere. And there's no way you can make a model. But with this system, we will be able to make a model, which is just beautiful, I find.
I think it is.
Now I understand what you was asking before, Wolf, because I was going to the wrong direction. My ideas, my clickables, wherever. No, now I know exactly what you want.
Yeah, so I'll just expose, I'll just hide these here and we'll just bring in.
Wolfgang, you've got that little video that you've sent me earlier.
Oh yeah, I don't know if I can get that right now. So hold on. Module, where is it? Here. So this, you'll have this one as a default, and then all you have to do is sync your impression in here, basically. And then you unify that, and that is already cut out, and then you vertex separate it. It's pretty straightforward. Anyway, I'll stop sharing my screen here.
Now I understand what you want, because in the beginning I was thinking more analogical way, that you have the model, you make the cuts, install the clickables, and later work. But now I understand. Soon, Michael, prepare the die, make the block die. This will happen like bloom, automatic will show base.
So the benefit in this system is we don't have to print a whole model. You only put the dies on the build plate, and you can fill your whole build plate full of dies. And so, you know, the failure rate is so little because the dies take up very little surface area. So I haven't had any dies misprinted. You're standing the die directly on the build plate. We use, actually, I should have this patented. Just joking. We're using the burn layer that expands. We use that for clipping mechanism. So if you imagine that the lower layer is swollen by maybe 80 microns, I'm using the 80 microns to engage into an undercut contained in the actual base. That means that when you're taking your die, you can actually hear it, it will actually clip into position, and the die's actually got good lateral support. So I'm very happy with the outcome so far. I've got a whole bucket full of prints, failures, but now I'm heading into success. So yeah, so it's good.
You are engaging the dies from the bottom of the model, and you clip them with the burn layer into the bottom in the undercut area.
Yes, the burn layer. The burn layer is responsible for the clipping mechanism.
Can I just share my? Can I just share my screen here?
Yeah.
Could I ask a question to Wolfgang?
Can you?
Yes.
Can you see my screen?
Oh, there's a question. Yeah. Sorry, what's the question?
The question is regarding the die system which you represented. I just saw it, and the question is, if I still want to print a Geller model, let's say,
yes,
with dies like that, would you be able maybe to put some part, let's say lower clip part for the base of a Geller model, so that I could eventually integrate my Geller model to your clip?
Yes,
but
yes,
just the base, because for me it's more practical that I have a Geller model in my hands than the proper dies or Accutrack or whatever.
Yeah. So you can have the body of the actual model serrated, but you can have the die bit as a Geller. So you can use both systems in that base on the articulator, and that is multi-patient per one articulator, which is a good benefit.
So actually the base, I just need to adapt your base to my Geller model, and then that's it, actually.
That's correct.
Yeah, without having the brighter position of each die or something. I just keep my smaller Geller model, let's say, and
Yeah.
by using the base, we can implement this into the articulator. It's
That's-
great.
Yes,
And-
that's
and
correct. Yeah. So
That's great.
it's looking forward to that.
Yeah.
Well, Wolf, can you see my screen?
Yes, I can see it. Oh, that's Bastian was painting today, my son. So
Can you hear the click? Can you hear the click?
no,
No, you can't.
no, you can't hear
Okay.
the sound of the
I
video.
can make it if you want.
Okay. Well, that's basically how it works.
Yeah.
I just wanted to show you what type of dyes that we're talking about here with the you know, when we take these. Now obviously when we're using an articulator like this, we would make the contacts a little bit bigger. We'd probably we'll cut out a complete section. So we would then take this, and when we survey and block it out, I'll just demonstrate, block out what it actually leaves us with.
You see,
And this is
because
what we're
under
talking
normal circumstances, if you've got a model scan like Michael's just had, it's very difficult to make a model or a dye system. So this is where we're heading to. So you can actually work on a model if you are presented with a scan like that.
So yeah, so a model that you can never make a model like this, never. So let us just have a look and see where my dyes are. Okay, my dyes are over here, and let's hide all of the other stuff. Okay, at the moment they're still conical, which I'm going to change, but it's these yellow bits that will then get inserted into Wolfgang's base structure. Yeah. So that then we've got a model. I mean, they don't have to be conical like that, but you know, I'm going to change that. But yeah, so that's the idea. That's the idea.
Got it. So question number 2. Not question. I just like brainstorming the next solution. We are talking like to have a fixed size base to receive the dice.
Yeah, I was talking about that.
Sorry, how do you mean the base needs to be certain size, or is it?
No, because what happens if you have like a uniform base size to receive the dice?
Yeah.
One approach. If you will print every time this base to receive the dice, is a different approach. What I'm thinking is not about the base itself, but it's about the material. What material you will print the base to be stable and reduce gap?
Yeah. So I mean, if you're confident with your printer, go for it. But we would say you can do with your printer, but we recommend you get it nylon printed. Okay. So selective laser sintering, that's the way we're thinking. And we do that through Shapeways. So we would have the design available on Shapeways, and then you can get it nylon printed. Of course, we'll do a couple of sample cases first, but nylon is a very strong material. And we're looking at durability for these things. We don't want it sitting on the articulator and something breaks. This is the best way to do it.
I think I can contribute with something. I am testing for engineers side of the resins, one special resin that's like extra hard resin for prototyping. So I'm doing some tests for these people. What we will be doing, I will test this special resin in this way to see how it goes. Maybe we can have a solution in-house. If you can have this resin, your own bases.
I think that's a good idea. If we can recommend something that works. So, you know, of course, you know, nylon is the Rolls Royce, but if we go for another one like an ABS type, I know there are resins that you can make molds with. Engineers make molds with those. If we
Exactly
can,
this one.
if the thing, what I'll do is I'll send you as soon as I finished early next week, Monday or Tuesday, I'll send you the design, and then it's in your hands to practice or experiment with that. And then give me your feedback before we, release this space here. But it's very exciting. I worked with different bases and plastic bases for years and years, because it saves you from standing on the model trimmer and all of that. But then of course that adds to an expense. You buy these bases in plastic injection molded, maybe 100 or 200 in one go. But wouldn't it be a good idea if you only need one? And this is a massive benefit.
Can we mile it in PMMA, in transparent PMMA? Like this, we can see the die fitting into it?
I think you could. Yeah, by all means, try it. I mean,
I think I will try it.
Milling is very, very accurate. But having said that, you know how I mentioned you've got the burn layer that clips into an undercutting area. I'm not sure if it can engage in there, the burr. So, yeah, so.
What I will, well, each one have idea. I will be testing this because what I'm thinking, Wolf, is sometimes you have just one size base, you will be like hostage of that base to work with your file.
Yeah.
What I'm thinking, you can have a resin, a special engineering resin, have freedom to any size of base. And if it's the cost of this printing will be okay, you can have like create one standard base or have
different sizes. Actually,
base.
it is scalable, Ivan. The base, you can scale it if you want. But of course, if you got one size sitting on your articulator and you scale it, maybe I'll keep the underside. The underside can stay the same.
And you can flip a larger
but we
one.
can scale the outside so it will still fit. That's the plan.
Yes.
Yeah. I see. I take your point, because some mouths are really big. We have to be able to scale this base, but it still has to fit on the articulator base. Yeah.
Got it.
Awesome. Well,
Excellent.
I think thanks for joining. It was a very exciting moment, and I think the crown and bridge is just incredible. And Michael, you've done a really good job. Congratulations.
Thanks, Wolf.
Awesome.
So have you recorded the session, Wolfgang?
Yes.
It's all recorded, so we
Yes.
we can upload it. Fantastic.
Good stuff.